All right, so in this previous video, we talked about how do we get a solution for simultaneous equations using graphical method or graphical representation of simultaneous equations. But in this video, we'll be actually talking about how we can achieve to the same result without actually getting into this trouble of making graphs and plotting all this stuff. We can actually do it algebraically. So let's actually discuss the method to do that. So we have these two equations together, and as we already discussed, what do simultaneous equations tell us about something is that they actually give us information about something, and they actually help us know about a solution of something, which we otherwise would not be able to get if we did not have, a set of two equations. Like if we only had one of these equations, we would never be able to find a solution of what would be y equal to for a particular value of x. There has to be, because there could be infinitely many values of x and could be infinitely many values for y, but we needed that one solution, 1 comma 3, that we were actually interested in, and we actually got to know because we had another equation that intercepted that first equation. Here we can see that in the graph, and we actually came to know, okay, this is the particular point that the both of the equations are talking about, right? So how do we actually solve this algebraically without actually having a need to draw these graphs? So first of all, y is equal to this. So this is the left hand side, which is y. This is the right hand side, which is equal to 2x plus 1. In the second equation, left hand side is again equal to y, but the right hand side is equal to x plus 2. So if y is equal to this, and y, this is the same y, is also equal to this, then logically we know that these two things are also supposed to be the same, because y is equal to this and y is also equal to that, so these two also be same, right? This is like saying the same thing as uh, there's a boy who is 21 years old, and there's a boy who is named, let's say, Alex. And if we are talking about the same boy, we know that Alex is 21 years old, right? So it should be given that we are talking about the same guy. Here we are talking about the same guy whose name is y, because we are not using any other variable to in the second equation to talk about. We are actually using the same variable, meaning that we are actually talking about the same set of this character y, right? So I hope that I did not confuse you. I just wanted to say that, if y is equal to this thing and y is also equal to this thing, then these things should also be equal. And how could these things be equal? We can write them down as like this, x plus 2, right? So since this was equal to y and this was also equal to y, so these are also supposed to be equal, right? So this is the point I want to make. This is called equating the two equations together when they are equal to a certain variable, right? So now it is not a problem for us to solve. It is simple matter of algebraic calculation, or we can solve it simply via the tools that we learn in algebra. We can just bring x over to the left hand side and subtract it from 2x, and we can bring 1 to the other side and subtract it from 2, and we can get x is equal to 1, and we just need to substitute this x into one of these equations. For example, we can take the equation number 2, y is equal to x plus 2, x is equal to 1, so 1 plus 2, and y is equal to 3, and we get x to be equal to 1 and y is equal to 3, and we can just write it down like this. So we got the solution that we actually obtained from the graphical method, without actually be able to draw graphs. So simultaneous equations could be solved just like this. We could use a couple of methods. One is called substitution method, one is called elimination method, but they are more or less the same techniques. You can use either, whichever you like. The one that I used in order to solve this equation here was more of a substitution method, because I substituted the values for y and equated them together. Like I just use this equation, y is equal to 2x plus y is equal to x plus 2, and then I just substituted the other value for y, which is 2x plus 1, and equated them together and solve it. In elimination method, you are supposed to eliminate one of the variables, and you just might have to subtract one equation from another in order to do that. But we'll be actually leaving that for another video. You could just use any techniques if that you are convenient with. So that's how you can actually solve simultaneous equations and get to a solution that they're talking about without actually having a need to draw graphs. So I hope it did make sense.